cosine of x. So the handout, which I do recommend you try to do on your own, asks us to compute some values of sine of x. So we compute the values the same way we always do from the unit circle. And when you're trying to graph it, to me, the most important things, and the things you absolutely have to have correct to get credit for, is that it goes through all the intercepts. So all the places where it crosses the x and y axis have to be correct. And then the maximum and min values have to be correct, right? So if we plug in x equals 0, so remember sine of x is the y value on the unit circle for the angle that you plug in. So when we plug in x equals 0, that means an angle of 0. We haven't rotated anywhere. And so you just go and find the point on the unit circle, right? So this has an x value of 1 and a y value of 0, right? Because we went over 1 and we went up 0. And so the sine value is just the y value there, which is 0. And then we can plug in other values, and the handout does ask you to plug in some other values. But in particular at pi over 2, which is 90 degrees, we're now at the top. We're at the highest possible y value. So we have an angle of pi over 2 is 90 degrees. We land up here at this point, and this point is 0 in the x direction and 1 in the y direction. So it's the y value of 1. And then if we go halfway around the circle, which is pi, we land over here. And this has -1 for the x and 0 for the y. So at pi, we're back at 0. And then if we go 3/4 of the way around the circle, that's 3 pi over 2. So remember that's pi plus another half pi, so 3 pi over 2. And that lands us down here at the bottom, which is 0, -1. So the y value for the sine is -1. And then if we go to 2 pi, that's all the way around the circle. And we're back where we started. So the y value is 0 again. And then it's just going to keep repeating over and over and over and over again. And if we went backwards, minus pi over 2. So that would be also 90 degrees going backwards this way, but now going clockwise, and you get -1. So it repeats also in the other direction. So when we're drawing the graph, like you will on your Friday assessments, what I recommend doing is you have pi over 2, and pi, and we have 3 pi over 2, and we have 2 pi, and we have 1, -1, 1 minus pi over 2, minus 3 pi over 2, minus 5, minus 2 pi. Okay, so what I recommend is putting in your dots. It's going to be like kindergarten, connect the dots, right? So we have these various different points. We have 0, 0. So plot that on your graph. And then we have a point at pi over 2, 1. So we go to pi over 2 in the x direction, 1 in the y direction. We plot that point. Then we have pi, 0. So pi 0. And we have 3 pi over 2 with -1. So 3 pi over 2 with -1. 2 pi with 0. We're back to where we started, and then it just repeats. And we can also go in the negative direction. It does the same thing, but it repeats in the negative direction. And so when you connect the dots, you have to be careful. So we don't actually have enough information from what I just did in this thing, but if you plug in more points accurately, it turns out, and you have to get this right also on the Friday assessment, this graph is not straight. It's not like a pointy mountain range. It's nice rolling hills and valleys. So physically to draw that can be hard. So the way I do it is to draw like a hill, it's connecting those points, and then separately a valley. Keeps going, and then a valley. This is also going to go through 0. Oops, did I do that? I'm sorry, I totally labeled this wrong. It should be minus pi and minus 3 pi over 2. Minus pi minus 3 pi over 2. So you get a valley on this side, that point, a hill on this side, and it keeps going forever and ever and ever and ever. When you draw it on your Friday assessment, you should draw it all the way across the axes that are given to you. So just drawing one little loop is not enough. You have to keep going forever and ever and ever and ever. And again, it should hit the maxes and the mins in the correct points. It should hit the x-axis in the correct points. It should be curvy and not straight, ever, ever, ever. This is our y equals sine of x. Cosine of x is the exact same graph shift it over, right? So you can go compute your cosine of x. Similarly, you can watch the Khan Academy video, but it is exactly the same graph. Just shift it over, make sure you shift it in the right direction.
So on that Friday assessment, would we like, what would we be given?
You're gonna be given a blank axis.
Just blank.
And you can go find out. So in the practice assessment, it has exactly what you're gonna see. So you'll see what you're gonna see on the Friday assessments. You can use that to get ready. When you're doing this, just so you know, this is not half circles. So if you look at a better drawing of this thing, oh, actually, let me do it here. If you go and graph this with, better than what I can do, like with Desmos is the handy dandy free graphing calculator. So this is sine of x. So first of all, if you do go watch those Khan Academy videos, which are great, you'll notice that if you pay attention, you'll notice that their x scale and y scale are not to scale. So pi, right, is 3.14159, so it's here, right, in here. So, and this is 1, right? So this thing is not circular. So in particular, you can look at the circles that you might think it is, right? So here in the middle, pi, this is a circle of radius pi over 2. It's way bigger, right? Or if you look at a circle of radius 1, which hits the max point, it's way smaller. So the sine graph is not like a circle within a circle, even though those values come from circles. So so you can graph this and you can actually change it so that it's intervals of pi. Desmos is really nice. So you can see also where it goes. And then also for tangent, when you're graphing tangents, you can do the same thing where you can plug in some points and find out what it looks like. When you're graphing tangent though, this is the way I recommend doing it. Again, in terms of like, how do we physically go about drawing it? So tangent of x, when you fill out your x and y values, you're gonna find that we have tangent of x is sine over cosine. So there are these places where it's undefined because you can't divide by 0. So it's undefined when cosine of x is equal to 0 because you can't divide by 0. And in particular, cosine of x is 0 when you hit the here's our sign, right? So cosine of x is 0 is all of pi over 2, 3 pi over 2 minus pi over 2. So in particular, it goes through 0, 0. At pi over 2, it's undefined. At pi, it goes through 0. At 3 pi over 2, it's undefined. And similarly, and you can go compute more values. But when you graph it, what I recommend doing, what I strongly recommend doing is, again, you have to hit the correct places where it hits 0. And then it's really important that you hit these, you get these undefined places. And when it's undefined for tangent, what happens is you get these vertical asymptotes. So at pi over 2, pi, here's 3 pi over 2, here's 2 pi. So at all the pi over 2 places, we're getting a vertical asymptote. And what you should do is draw a dashed line. This is not part of the actual graph. It's just telling the person who's looking at your graph that you have a vertical asymptote. And it's helping you to draw it. So at all those places, draw in dashed lines, minus pi, minus 3 pi over 2. Draw in dashed lines. Draw in all your zeros, goes through 0, 0 at pi. And then it has this sort of S curve shape, which also can be hard to draw. So I also like to draw it in 2 pieces. So it curves up like a smile and has this tail that leans up against but never hits that dash line. And then it does the same thing going down, but like a frown that way. Right. And then you have to draw one piece is not enough. You have to draw it again. So it repeats over and over and over again. It's also a periodic trig function.
Is cotan like the other side is up?
Cotangent.
Like how the
Cotangent has the zeros are at the sine, at the places where sine is 0.
Okay.
I mean, the undefined places are where sine is 0, and the zeros are where cosine is.
Okay.
Right. So its cotangent will have the asymptotes and the zeros sort of flip.
Okay.
You will have to draw it for our Friday assessment.
But this is not whatever you would call the shape you get from a cubed graph.
That's different.
That's
Yeah, good
different.
question. So y equals x cubed looks kind of the same if you're not paying careful attention. So the tangent graph zooms up to infinity at pi over 2, minus pi over 2, and all these other places. X cubed does go to infinity, but it doesn't have an asymptote at a particular point. It does have this same basic shape, and if you don't know what's happening, it can look the same on the graph. Y equals x cubed also sort of looks like this, but it doesn't like stop at some point and shoot up to infinity. It just like gradually goes to infinity forever in that direction.
We're doing this for tangent.
Yeah.
Is there, is this based on unit circle? So why would there not be a maximum at 1 and or minimum?
Because when you hit that maximum at 1 for sine, for example, you're dividing by 0. And that's what happens. That's why you get this like undefined thing. If you watch the Khan Academy video, it goes into a little bit more detail how you're like your slope is getting bigger and bigger and bigger and bigger and bigger, right? And that's what's happening. But yeah, so it's not, you're not hitting 1 because you're dividing by 0.
How do you do it again?
On the practice assessment for F4. So this is F4. You're just gonna have to graph sine, cosine, and tangent. It's exactly the same thing every time. Just memorize them. And at the end of this practice assessment.